Okay, hello and welcome. Just wanted to make you aware of one very important thing coming up next week before we hop into today's material, which is the fact that we got exam 1 coming up on Thursday next week. So definitely, I'll be posting an announcement to Piazza sometime in the next day or two with a lot more information about where to go for the exam and stuff like that. But the main thing that I wanted to bring to your attention for today is that during this time slot next week, we'll be doing exam review in here. So yeah, you can still plan on coming here next week and asking questions about the exams. There's already some exams from past semesters posted if you want to take a look at those. And like I said, I'm going to post some more information very, very soon. So just want to make sure you're aware of that. It's coming up pretty quickly. So otherwise, I think we're cruising right along. Question? Chip?
Is there no studio on Wednesday?
That's correct, yeah. Because of the exam, we're not going to be doing studio next week. So there will be review and demo times here, and then you can turn stuff in or ask help. But Thursday is basically the exam day next week. Yep. Alrighty. Yes? Yeah, great question. So the exam's going to cover the first 3 modules. So what we're doing today is going to be on the exam. This is the last section of material that's going to be covered on the first exam, what we're doing today. So, yes, there absolutely will be coding questions on there. I have posted exams from the past, so you can take a look exactly what I've given in past semesters if you want to see. And yeah, so next week, definitely there's not going to be as much of a schedule in the sense that I'm not going to have new things to talk about. So please come with questions of your own or ideas of practice problems that you would like to see me work through the solutions of, because that's how we're going to be spending the time here next week. Okay. One other little thing I want to mention before we hop into the material today is that while the first 2 weeks of class I wouldn't say were easy by any means, I think that weeks 1 and 2 the material is a bit conceptually easier for people to pick up. Assignment 3 and module 3, when we talk about arrays, the content that we're talking about today, can be one of the first real struggle points for a lot of people. And that doesn't mean that you're going to have problems with it, or maybe you're already struggling with some of the material in the past. If that's the case, I would definitely recommend, please come see me, right? If you're still having trouble understanding loops and if statements, the stuff that we talked about last week, trying to forge ahead and talk about arrays, this is probably going to be really, really tough. A lot of the material is going to build off of each other. So I would actually recommend probably pumping the brakes and making sure you understand the past material fairly well before trying to move on. And again, if you think you fall into that situation, I really hope you come see me. I am happy to go through any exercises, homework assignments, practice problems, whatever you need to get you back on track. So just a little bit of fair warning, but we are going to be talking about arrays today. And to understand why arrays are so important, I want to kind of bring you back to this idea that we saw a little bit ago where I think I was trying to compute the sum of all the numbers from 1 through 5, and then all the numbers from 1 through 10. And, if I wanted to do all the numbers from 1 through 100, that gets really tricky without a loop, right? So if I want to do lots of repetitions, trying to type it all out, trying to type all those repetitions out becomes very cumbersome. Instead, I want to use loops probably to track that instead. But loops only solve part of the problem. So consider that while yes, a loop does allow me to repeat something, what if I want to, track weather data like high temperatures over, every day of the year for 10 years, right? That's a lot of variables that I have to create, one for each day, for example. So the fact that I have a loop that lets me do a lot of repetitions does not solve this problem of, if I have a large enough data set, storing each individual item from that data set as its own single unit, right, becomes too cumbersome. I need to have a way of combining my data, treating it as one big set of data when it's appropriate to do so. And so that's what arrays are for. Arrays are structures. I think of an array really as just a set of buckets that I can use to contain data. So instead of having a variable refer to one value, I'm going to have a variable refer to an array where that array contains multiple values. And it's up to me as the programmer to determine some characteristics about that array. Specifically, the things that we're usually interested in are how big is that array going to be? How many things does it contain? And then also the type matters a lot to us. We are not going to see mixed types inside of an array. So I cannot see a string and an integer inside of the same array. I can't see ints and booleans or ints and doubles or any types mixed together. So it's going to be an array of integers, an array of strings, etc., etc. And so here's an example of how we would start to incorporate these into our code. First thing we're going to do is create an array. And I'm creating this, it starts out just like creating any other variable. We do see the first difference, though, with the introduction of these square brackets. So these square brackets are a really big flag, right? Anytime you see those square brackets in the code, your brain should, I really want you to associate that with arrays, right? At least for Java code. That won't always be true, but for the most part, square brackets are going to be dealing with arrays. So the way to interpret this type, it's not an integer, but it's an integer array that I'm creating as the type of this variable, that I'm using as the type of this variable. This is just the name of the variable. So just like we've seen before, you can call it whatever you want to. We've got our equal sign, and then the stuff that comes after the equal sign looks probably significantly different. If I was creating just a single integer, I would see, the number 7 here or something like that, right? But I'm not creating just one integer. I'm creating a structure to hold many integers. So this code over here is saying that I'm creating an integer array that can hold 10 things. So this is the size. I'm telling you that this is how big this array is going to be. And once I have specified that size, that is it. That array has exactly 10 buckets and will forever have 10 buckets. I cannot shrink that array later. I cannot grow that array later, right? Which may sound inconvenient. In fact, it is quite inconvenient that we're not able to do those things. We have little workarounds and other ways that we can deal with that problem a bit later on. But that does not change the fact that once you have constructed this array with 10 spots in it, it will forever have 10 spots in it. So the size of an array is not going to change. Okay, so if I want to create arrays of different sizes and different types, then it's just up to me to swap out the types that I want and the sizes that I want. So for the examples that we see down here, things should be fairly straightforward to create not just a double, but a double array. Like I quite literally read this, I don't say double bracket bracket, I say double array. I literally just say the word array when I see those square brackets show up, because that's what that represents. So that's an okay association to make. I would encourage you to also talk about it like that. They tell us they want the array to be called prices, so we can call it prices. I'll set an equal sign. I have to type this word new when I'm creating arrays like this. We've seen this word before. Anybody remember where we've seen that word show up before? Yeah. Scanner, that's right, for the scanner. We don't see it show up for integers or booleans or doubles or things like that. We did see it show up for the scanner. We're going to see it show up a lot more often. So here it is showing up again, that word new. It's going to show up a lot more often, especially in the last part of the semester, towards the end of the semester. We're going to see it a lot more frequently. But for now, we're going to create a new double array with a size of 5. And the last one down here says array of 5 strings called names. So here's a string array called names. And we wish that to have a size of 5 as well. And if you're ever unsure what the size of your array is, you need to go back and ask that question again, we can see that there's a way to request that information by just saying the name of the array dot length. That will specify how many items that array can contain. And again, remember that this will never change. If I create this array with 10 spaces in it, this will forever be 10. So this is how we create arrays. But these arrays, after they're created, are empty, kind of. Like, what is in them, right? So there is what we would call default values. I think the default value for ints and doubles is going to be 0. It's just going to fill it all with zeros. For strings, I think it's just going to be an empty string. But you'll notice that I don't sound super sure because I don't really care. Whatever's in that array is probably not actual data that's useful to me. It's just filler, right? It's just a placeholder. So I need to have a way of getting actual useful information in there. So these arrays, while they certainly, we've created them, they exist, they're basically empty. They're waiting for information to come in. This is such a common thing that we actually have developed a second way of creating arrays to allow us to just fill them with information automatically. So the second way that you'll see to create an array is like this. The space that you see here in between the brackets doesn't actually do anything, but it bothers me. I can't really explain why, it just does, so I take it out. But anyway, this is going to create an integer array. You don't see the new, int syntax. You just see curly braces with some values. This is the contents. We're actually saying, all right, I want to create a new array and I want it to have this stuff in it. So don't use the default values. Don't fill the zeros. Put these values in. And then what will it use for the size? Well, it's just based on however many things you see here, right? So there's 5 things on this list. The size of this array is going to be 5. So there's 2 ways to create an array, right? I can create just an empty array and then fill it later. Or if I know what I want the values to be, I can just go ahead and create it and fill it all in one line. I want to show you, though, I want to actually double back and show you what it would look like if we did it the other way, to fill values. Here, we've created an array with 5 values in it. And each of those 5 buckets, when we create this array, gets assigned a number, a position. We call that the index. The computer does this for us automatically. And if we were doing this as humans, right, we'd probably say the first position is 1, the second position is 2. But we don't do this. The computer does this, and the computer says that the first position is 0, not 1. So that means if there are 5 things in my array, the positions are going to be 0, 1, 2, 3, and 4, right? 5 is not a valid index. There are 5 things in the array, yes, but there is no address 5. There is no index 5. The last index is 4. And that's true regardless of the size, right? If there's 10 things in my array, the address of the last thing is going to be 9 because we start counting from 0. Does that make sense to everyone? I hope. So you can see that reflected here. If I create an empty quote-unquote array and then I want to fill it, then I actually have to take a value and assign it to a specific position within the array. So I can't just say high scores equals 99. High scores is 5 buckets, right? I have to be specific about which position I'm talking about. Put the 99 in the high scores array at position 0, right? That's what this is saying. Index 0 of high scores should be 99. Index 1 should be 98. Index 2 should be 98. That's what these lines are saying, right? But again, I want to reiterate, the point I'm making here is that this code that we see setting all of these values and the code that we saw in the prior example, these are equivalent, right? These are equivalent. And I think most people would agree that, doing it this way is a lot more concise, a lot more straightforward, but requires that you know what those values are. If you don't know what those values are, if you have to ask the user for them, or you're reading them from a file or from the internet or from some other place, right? Then you don't have a choice. You have to do it this way. So you have to know how to do it both ways. Okay. Cool. Last, but certainly not least, I want to introduce this idea of what's called parallel arrays. Parallel arrays. So you'll notice that in this example, array 4, I actually have two arrays here. I have my high scores array that we've been working with, and then I created a second array, a string array called names. And what I want you to notice is that down here, when we get to the bottom, it's printing out one value from the names array, followed by one value from the high scores array. And it's using the same index, right, for each one. And the arrays are the same size, they're the same length, right? So the reason these are called parallel arrays is because they line up, right? I'm saying that Jamal got this score, Emily got this score, Destiny got this score, right? I'm using two arrays to keep track of two different sets of information, but the indexes, right, the indices of those two arrays both mean this, they refer to the same thing. They're linked. There's a relationship. Very common technique, right? Very common technique to use. And the reason that I, kind of bring this up, you can see that while we like to do this, is a useful technique to use, it does have some limitations, because if I come down here and I want to print this out for, all 5 of these people, that's maybe not too bad. I just have to copy this line 5 times, but you might see where I'm going with this. If I have 100 high scores or 1,000 high scores, this now becomes very tedious, very problematic, very cumbersome. So we need a better way. But we've got a better way, and you already know about it. What we're gonna do next is talk about how to traverse arrays to visit all of the items within an array. But before I switch to the next topic, I just want to pause here, see if anybody has any questions about creating arrays, accessing array elements. The idea that an array starts at 0 and ends at 1 less than the length is very important. I can almost guarantee that you're going to see that show up on the exam next week in some form. It's pretty much a promise, right? Yes?
So the only way to change the size of the array after creating it is to go to the place create and change the size.
Well, I want to be a little bit careful about what I mean when I say you can't change the size of an array. So I can change this number anytime that I want, right? And then rerun the program, and it will create an array using whatever number is in here. But what I mean when I say I can't change the size of the array is that once I've created this array and it's got 10 things in it, later on in the code, right? Later on in the same program, I can't make it 12, right? If I want to change the size of this array, I have to stop the program entirely and then change the code and then start it over again in order for those changes to take effect. I can't decide mid-program, oh, this array needs to be bigger or smaller. Does that make sense? Like I can't change the size on the fly, right? Which is still very inconvenient. There is, so one way that you can get around this problem, not that I recommend it, but this is a very common quote-unquote solution that people discover frequently is, well, if I want to make my array bigger, I'll just make a bigger array and then copy it, right? And now I have a bigger. But that's inconvenient, right? That's cumbersome too, which is why I don't really recommend it. We'll talk about this problem a bit later on as well. Any other questions? So if I have an array and I want to visit all the elements within an array, we're going to use our good friend loops to pull this off. Actually, I don't want to look at that example. I want to look at this example. Sorry. So here's an example using a very similar loop of array of strings that's going to go through and loop and visit and print off each item from the loop. And so the way that it works, here's our for loop. Remember, we got 3 pieces of a for loop. Where does the loop start? You can see that I is starting at 0, chosen very intentionally, right? Because the index, the address, first address of an array is going to be 0. So that's very common. The condition is given as I is less than the length of the array. Strictly less than. So it's one of the more common mistakes that I see here would be to say less than or equal to. But I've already talked about this before, right? If the length of the array is 5, then allowing I to be equal to 5 doesn't work. There is no position 5. The last position is 4. It's 1 less than that. That's why it's strictly less than, right? And then I is just going to go up by 1. So when I look at this print statement here, if I think about the values that I is going to take on, it's going to start at 0, 1, 2, 3, 4, and then I'm done. That's 5 values, right? 0, 1, 2, 3, 4. 5 values. And so if I print this out, or if I run this program rather, I would hope to see the contents of the array printed out. And that's exactly what I see. But wait, you might ask, some of you may have already tried this, or be wondering why I didn't just do this. Can't I just print out the array? Okay. The array is in a variable. Can't I just print it? Well, let's try it and see what happens. If I try to print out the array that way, I get this. Which actually is information. I can tell you what this is. You can probably already kind of figure out what some of this is. That's the type. There's the type right there. This part over here is the address, quite literally the physical address on my laptop where that array is on my computer. Your computer, the number's probably going to be different, right? Because your computer is different than my computer. But so a little bit interesting perhaps, but completely useless to us and what we're doing right now. This is not how we print out the contents of an array, at least not in this class. If we want to print out the contents of an array, we're going to have to write a loop to go through and visit each position and print out that value. This is such a common thing. This loop right here is so common. I mean, it goes hand in hand with arrays. You're going to write a loop that looks like this. I can't tell you how many times in this class this semester. Draw a star next to that one. I mean, it's just it's so common task to do. Any questions about that? Yes? Yeah, I'm looking at that one next. Yeah, that's where I'm going next. This one here. Well, did you have a specific question? I'd be happy to talk about it.
Yeah, I mean, if I just miss the first one, I start from 1, but the program can run perfectly. It can run normally, but I miss the first one. Is that also a error?
Well, and so the question is, you missed the first one. So let's talk about that for a second. Here, I starts at 1, which, we've been taught to count from 1 for our entire lives since we've been born, basically, right? So this is a very natural thing for us to want to do, to count starting from 1. But this is not how the computer is going to do it, and would have the effect of jumping over that first value, right? So you just asked me if that's wrong, and the answer is it really depends. What problem are you trying to solve? If the problem is to take the average of all the values in the array, then yes, that's wrong, because you just skipped 1, right? But if you have a good reason to skip the first value, then maybe it's not, It all depends on the context, depends on the problem that you're trying to solve. I would say that in most situations it's probably wrong. The bigger issue here, though, I think is this. So while I don't like seeing I start at 1, there's not... It's perhaps less of a problem than the condition. What's wrong with this condition? This is going to crash. This is going to crash the code if I run this. So here you can see that 10 is the first value in the array, but the first value that I see is 9 because we skipped it. We skipped 10 since I starts at 1. But perhaps even more of a problem is the fact that we got this red text down here, and it says array index out of bounds. So that's computer speak for saying you went off the edge, right? You went off the end of your array. You went too far. And it even goes further to tell you index 4 out of bounds for length 4, which if you saw that, prior to today, might have been a very confusing statement. But if you've been paying attention, that actually makes a lot of sense, right? If the array is size 4, then an index of 4 is not good. That will never work. But even more important than that, it tells you where the problem is, right? I think it's really trying to help you out here. This number right here that comes after the colon means that it happened on line 11. And if you click on this, it'll even tell you. Here it is. Here's the line where this problem happened, right here. This is the line where the problem happened. That's very useful, right? Hugely, hugely useful information. But it's still your job as a programmer to take all that information into account and use it to help fix the problem. Because what you may notice is that while this is where the error happened, there's nothing wrong with this line of code, right? That line of code is fine. So yes, that is where the error occurred. That's when we noticed that there was a problem. That's not where the actual problem is with our code. The actual problem with our code is up here. So the error got us in the right ballpark. Still, our job as the programmer to look at what's happening around that area and figure out what the actual problem is. You cannot just assume that that's where the problem is, but it's at least close. And so to consider that here, we see, all right, if I can be equal to 4, that's too much. It's always going to be strictly less than the length. Always, always, always. And, that will make the error go away. So now I can see no more red text, but really, if I'm trying to capture all the elements in the array, I should start from 0 as well. So both the lower and the upper bounds of the loop were off here. This is such a common thing. I see this all the time. All the time. So I don't want you to feel bad about this. I mean, I've made these kinds of mistakes too. It's very natural. What we're asking you to do by starting to count from 0 is unnatural, right? So it's, I think, understandable to fall into these kinds of traps. Okay, unless there's any other questions, I'm gonna hop into the next topic. I'm gonna show you a new kind of loop, kind of. So we've already seen 2 loops, for loops and while loops. But I'm gonna show you another kind of for loop. So there's actually 2 kinds of for loops. I've shown you this kind of for loop a lot with the 3 pieces, right? This is the classical for loop. There's another kind of a for loop called a for each loop. And so what we can see with a for each loop, it looks a little bit different. I don't see those 3 pieces anymore. I now only see 2 pieces. And the way that I would interpret this loop, if I was reading this, in English or trying to explain it to somebody, I would say, for each integer value in the high scores array. That's how I would say that out loud, right? Or I might just say for each value in high scores. That's how I would interpret that loop in English. And to think about how this works in code is to then think that this value here, this variable called value, is not going to go 0, 1, 2, 3. It's not going to count up by the index. It's going to go 10, 9, 8, 8. Every trip through the loop, it's going to take on one of the values from the array, not one of the indexes, right? In fact, the index is nowhere to be seen here. I'm printing out each of the values from the array and basically saying, I don't care what position it's in. I only care about the value. I don't care about what position it's in. Does that make sense? Yeah? So you might get to the point where you're faced with the position of, you need to write a loop. Do I write it as a for, int I equals 0 loop, or do I write it as a for each loop? In some cases, it won't matter. You can choose either one. And just like we've seen at other points in this class. If that's in fact the case, then I don't care. You can pick whichever one you want. You can write it as the more classical style loop. You can write it as the for each loop. Whichever one you're the most comfortable with. It really does not matter to me. And so with that in mind, I think this little exercise here, what does that look like if I were to rewrite this loop into a for each loop? You can see this is the classic for loop. Starts from I equals 0. Instead, we're going to remove all references to I. Just get that out of there and replace it with, you might call it value or number in values. For each number in values, right? And now anywhere that I'm referring to the array, or specifically a value from the array, I now just replace that with my loop variable. And we've successfully converted this loop from the classic for loop style into this new for each loop style. They're equivalent. The way that it was written before and the way that it's written here now are in fact equivalent. And you can see that if I run this code, it says even, even, even. By the way, what's this operation called again? Mod, yeah. This is a good time to kind of review this because you're going to see this coming up in the next studio/assignment. We're looking at numbers and telling you whether they're even or odd. So this is saying if this is evenly divisible by 2, must be even. I divide it by 2 and the remainder is 0, right? 2 goes in an even number of times. Must be even. It does bother me that there's no brackets here. That bugs me a lot. I wish, yeah. That's more of a pet peeve thing, I guess. Okay, but then there are times when using a for each loop is maybe not a good choice, or not the best choice, perhaps, or vice versa, right? So in this example that we were just looking at a few moments ago, this is the second time that we've seen this idea of having parallel arrays, right? This idea where, Jamal got this score, Emily got this score, Destiny got this score, right? But the whole idea of parallel arrays is built around this concept that the position matches up. The position from this array matches the value in the position at this array. That's how parallel arrays works. So to write a for each loop here, which is as shown, well, you can do this, right? It's technically not wrong to do this. I have no idea what position this value is in. So if I want to know who is associated with it, if I want to know the person associated with it, I have no easy way of doing that with the way that this loop is written. Do you see that? Do you see? So I actually think that if you're using parallel arrays, using for each loops is actually a bad idea most of the time. You're actually probably going to want to use the version of the array where you're using I to vary the index so that you can use that index to access more than one array. But if you're not using parallel arrays like this, then using a for each loop may be a perfectly reasonable way to go about things. Again, it's your job as the programmer to try and assess the situation and choose the best tool for the job. Any questions? I guess one final thing that I might say, just in my own personal experience, while I'm certainly a big fan of for each loops and I do write them, I've written far, 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 far more loops of the classical for int I equals 0, I less than array.length. That version of a loop will get you very far in life. So if you want to pick, if you want to get very good, if you want to master writing those kinds of loops, there's a lot of stuff you can do. You will not necessarily be limited. That being said, I think it's good to be aware that these things exist because you're not the only person writing code in the world. You're going to be reading other people's stuff. You're going to have to know how that works too. So it's still good to know. All right. Any questions before I move on to the next topic. Okay. So we're going to step it up a notch. Everything that we've looked at up until this point, the arrays, I have a length, and you can see this looks very much like a straight line. I've been telling you the length of the array, but to be more specific, what we've been specifying is actually the number of rows of the array, to be clear. So the computer actually thinks of, all of your arrays as being stored, whether we as humans are aware of that fact or not, as being stored in terms of rows. And actually, if we want to, we can extend that idea by adding another dimension, which would introduce the idea of columns into the mix, which now gives us not just a one-dimensional array, but a two-dimensional array. So it would be a rectangle, right? Two-dimensional array. I now have rows and columns. Turns out that can be a very useful construct for us as well. Also turns out that, we're not limited to just 2 dimensions. Turns out, as human beings, we deal well with things that are in 3 or fewer dimensions typically, but computers don't care. You can make arrays with arbitrary numbers of dimensions, very large numbers of dimensions, should you choose to do so. However, we're going to keep things simple in this class. I don't think you'll see anything with more than 2 dimensions. You might see a 3-dimensional array every now and then, but probably not. We're going to keep it simple, stick it with 2 dimensions. Let's take a look at what it means to add a 2-dimensional, or to have a 2-dimensional array. You can see right off the bat that when I look at the type tells me that this is a 2-dimensional array by having 2 sets of brackets. That's not an accident, right? So 1 set of brackets, that's a 1-dimensional array. 2 sets of brackets, that's a 2-dimensional array. So the number of brackets that I see here tells me the number of dimensions that my array is going to have. And in this class, you might see 3 brackets, but I doubt it. I think 2 is probably as high as we're going to go in this class. And you can even see that the way that we construct that array looks a little different too. The way that this has been written is actually trying to mimic the 2D structure. That's done intentionally, right? So I can see that every row is in curly brackets, and then the entire thing is also in curly brackets. So lots of curly brackets. But there are 3 rows, 1, 2, 3 rows, and it looks like 2 columns, right? 2 columns in this array. And so with a 1-dimensional array, we saw that the first position is actually at position 0. So it should probably not be a surprise that with a 2-dimensional array, we need 2 addresses, a row and a column. And the first one is going to be 0, 0. Row 0, column 0. It's the first element of the array. If I'm trying to visualize this 2-dimensional array in my brain, or if I'm sketching it out on a sheet of paper, both of which I highly recommend you do, if you're trying to work through a problem, position 0, 0 for me is top left corner every time, which I know is not how you learned it in math class. It'll probably be bottom left corner depending on your coordinate system, but for 2-dimensional arrays, row 0, column 0, typically I visualize as the top left corner. So if I print out the value at position 0, 0, you can see here I'm retrieving the value at position 0, 0, row 0, column 0. So this is always the row, and this will be the column. Row first, or we would say that's row major order. So the name that's at position 0, 0 is going to be the very first name in the array, which is Jamal. So I print this out, that's what I would expect to see. Jamal is at 0, 0. Okay? So then if we want to get a little bit more detailed, right, about how the array positions work, you can see we can create the arrays this way as well. So create an empty array with default values in it, but this time you can see we're specifying 2 dimensions, the number of rows and the number of columns. So I now have 2 rows and 3 columns in this array, and 3 rows and 2 columns in this array, right? And then we can set each one of those, 0, 0, 0, 1, 0, 2. So setting all the values in row 0, setting all the values in row 1. Similarly, for this one, you can see row 0, row 1, row 2. Right? Again, just a matter of whether you know that information up front or whether you have to add it in later. But it's the same idea. It's the same idea. Any questions so far? I mean, I really haven't shown you anything that's that different. It's just one additional dimension, right? But let's talk about traversal. Let's talk about traversing the arrays, two-dimensional arrays, because that is definitely worth talking about. You'll see that if I wish to visit each element of a two-dimensional array, like I was doing for a one-dimensional array, I'm going to use loops, but I need 2 loops now, one for each dimension. So the first loop is taking care of the row, and the second loop is taking care of the column. And they've been written here in such a way that the loop variable is named appropriately. I think that's a great idea, right? So that you can see this one's taking care of the row, this one's taking care of the column. So let's think about that for a second. The row is going to go from 0, that's always going to be the starting point, to now I see, a.length actually tells us the number of rows. So if it's a two-dimensional array, a.length tells us the number of rows. If it's a one-dimensional array, a.length is just the number of things in the array, which is actually just the number of rows. If you want to reconcile that in your brain, consider that the computer visualizes a one-dimensional array as just a vertical vector, right? If that helps. For the number of columns, though, how do we extract the number of columns out? So here's the loop that deals with the columns. Again, starting from 0. But here is how we can ask for the number of columns from an array. And to work through this logically, we're saying, all right, go to the array, row 0, the top row, and tell me how long that row is. The length of one of the rows should be equal to the number of columns in a rectangular array, right? If I go pick out one row and I count how long it is, that should be equal to the number of columns. So this stretch of code here is how we ask how many columns are in an array. What is the length of the 0th row? So I've got 2 loops here, one loop inside of the other, and we saw this structure last week, and it's going to count very similar to what we saw last week, in fact, where row is going to start at 0, column's going to start at 0, but since column is in the inner loop, it's going to spin faster, right? The inner loop spins faster than the outer loop does. So it's going to go row 0, and then column's going to go 0, 1, 2, 3. Or I'm sorry, it's just going to go 0, 1, 2, because there's only 3 columns, right? And then row's going to go up to 1, and then column's going to go 0, 1, 2. If you're visualizing your 2D array, right? 0, 0 in the top left corner, we're going left to right, top to bottom, just like we're reading a book. Go across the top row, go down. Go across the next row, go down. Go across the next row, go down, right? That's how we're visiting the elements in this array. Does everybody see that? I hope. Just like we're reading a book. Yeah?
So if we have 3 rows, then for the number of columns, instead of 0, we can put 2.
Okay, so here's the issue with using any number other than 0 here, right? While so you're correct. If you know that your array has 100 rows in it, right? Then I could put 50 in here and it's going to work, right? All the rows should be the same length in a rectangular array. So the number that I use here really ultimately doesn't matter that much, except, you know, if we're thinking about what happens if we're wrong. If I don't have this number of rows, then the whole thing comes to a screeching halt, crashes my program. So with that in mind, the safest row to use is always going to be 0. Right? Because even for arrays that have very small numbers of rows, they're going to have a row 0, because that's always the first row. Right? If I have 100 rows, there's going to be a row 0. If I have 1,000 rows, there's going to be a row 0. If I have 100 rows, there may not be a row 500. If I have 1,000 rows, there's a row 500. But why would I take that chance? There's always going to be a row 0. Right? Does that answer your question? I hope? Yeah. Cool. And so then within the within the loop itself, you can see that when we're accessing the array, I have to have 2 indexes now, one for the row and one for the column. One address is not good enough. One address is not good enough to get me one piece of data. I have to have 2 indices, one for the row and one for the column. This is actually averaging all of the values in an array, which is not a, that's certainly a practical thing to do. Has many uses. I honestly just care more about this double loop structure. So just like I told you for that loop structure looping over a 1D array, how are you going to use that a bajillion times in this class? I mean, similar story here. If you're using 2-dimensional arrays, you're going to probably be using this nested loop structure. I don't want to make any guarantees. I don't like to speak in absolutes because there's always going to be exceptions. But this nested loop structure and 2-dimensional arrays are very commonly used together. Very, very common combination to see used together. So certainly something that I would encourage you to become familiar with. That being said, so while this is by far the most common way to deal with 2-dimensional arrays, very convenient that it goes left to right, top to bottom, just like reading a book. There may be reasons for us to traverse the 2-dimensional array in another way, right? So maybe instead of going across the rows, I'd rather go down the columns. Maybe my data is structured in that way, so that the columns are where the meaningful information lies and not the rows, right? That's certainly possible. And we could certainly write code that will allow us to traverse going down the columns instead of going down the rows. And so there's an example given of just that. I want to show you, though, that really the only difference is that the order of these 2 loops has been swapped. The innermost part here even, right, that print statement is basically the same. So these didn't switch, right? Just the positions of these loops switched, such that now the row is going to spin faster than the column. So I'm holding the column steady and then changing the row. So column 0, row 0, 1, 2. Column 1, row, So you can certainly switch it and traverse your array in whatever direction you need to, but, as human beings, we very much stick to what we know. And so this version of the nested loop, very, 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 very much more common for that reason. All right. Any questions? So I've actually covered all the prep. We still have half an hour left, though. So unless anybody has any questions, what I'm going to spend the rest of the time doing today is just going through as many of these practice problems as I possibly have time for. Last time I didn't get through all of them, but I got through a good chunk. So I think we can get through at least 8 or 10 of these with the time we have left. But just want to give one final opportunity to ask questions. Yeah.
This isn't about a race, but I was noticing that in flows, when you declare a variable within the flow, you can't call it outside of the flow. And someone I know who is a little bit more advanced in CS called a scope.
Yes.
And I was wondering if you could briefly
Mhm.
explain what scope is.
Absolutely. So the question was about variables and this idea that if I declare a variable inside of a loop, so here's a new variable, it doesn't matter what it is. The idea is that I declared this variable inside of this loop. If I try to use it down here, right, the computer is going to say, I don't know what you're talking about, right? Cannot be resolved to a variable. It's basically saying, I don't know what this is. which seems a little silly. I mean, it's right up here, right? But let's think about why that's happening. It all has to do actually with these curly brackets. So the rules say that if I declare a variable inside of a loop, I can only see it inside of that loop. And the loop is bounded by the curly brackets. So the way to think about it is that because this was created inside of these curly brackets, as soon as I hit this closing curly bracket down here, this variable no longer exists. It's cleaned up. It's removed. The reason of that is to try and encourage you to create the variables close to where they need to be used. We don't want to have a lot of data laying around unnecessarily, so we want to try and keep it local when possible. You are correct that the name for this is called scoping. Where I can access a variable is the scope of that variable. We'll talk about that in a lot more concrete detail. I think actually shortly after the first exam, we'll see that come up again. But the quick, short version, at least for now, is to just remember the curly braces, right? If I create something inside of these curly braces, then as soon as I leave those curly brackets, it's gone. I can't see it anymore. Yep. Any other questions before we do some exercises? Okay, great. Then I'm just going to hop right in and crank through as many of these as I have time for. This first one, I think, just has some errors that they want us to fix. So the idea is that this program is supposed to print out this array backwards. They want us to start at the back end and go 15, 9, 7, 3, 1. That's what they want us to see. But there's some problems with this code. I think the first obvious problem is that they called the array A1 here, but then didn't use the right variable name there. It's not strictly, a problem, but I hate that they didn't put brackets in. So even though you don't necessarily need them, it makes me feel better to have the brackets in there. Even if we fix those little issues and run the code, though, we still have a problem. I didn't get anything. I just got this red error right away. It says index 5 out of bounds for length 5. And it's not the first time we've seen this problem today, right? So I know that there's a problem. I'm going out of bounds. What do I need to change to fix this? Or where in the code is this? There we go, right here. So I'm setting the value of I to be the length of the array. For this example, that would be 5. But there is no position 5. So down here, when I plug in 5, the very first trip through my array, it says, go get the value of position 5, and the computer says, I don't know how to do that. It doesn't exist. Remember, the position of the last value is always going to be at 1 less than the length. So if I run that, if I subtract 1 from the length, okay, helps a little bit, but 15, 9, 7, 3. We missed this one. How do I fix that? Yeah, I think you could do greater than or equal to 0. So again, consider here that 0 is a valid address, right? A valid index. I do want to include 0. So saying that I has to be greater than 0, that's stopping 1 too short. I want to allow 0. Should be strictly greater than or equal to. There we go. That looks better. Okay. Let's see. Number 2. Rewrite this program so that it prints all the values using a for each loop instead of the given for loop. Okay, we already had one of those, but that's okay. Good practice is always beneficial. Here you can see we've got our for each loop. They're spelling it out. Normally it'd say for int I equals 0, but I, surprise, surprise, is typically short for index, right? So here they're writing the loop using the index. And again, I want to reiterate that there's nothing wrong with doing it this way, right? If you write your loops like this, I will be very happy. If your code works, I'll be very happy. But I do think it's useful to know that these two types of loops exist and how to switch back and forth. So instead of relying on the address here, we're going to switch this up, and rely on the value. For each value in the array, print out that value. And I'm making the claim that this code is functionally equivalent to what we had up here before. We can run it and see. There we go. All the values. Cool. Problem number 3. Here we go. Problem number 3 says, complete the exercise such that it prints out all of the odd values in the array. And maybe there's an alarm bell going off in your head right now. It says, didn't we see an example that did all the even values in the array earlier today? And yes, we did. So from there, I hope that you might go back and try to find that example. That's what I would want to do. Instead of sitting here staring at this blank screen trying to remember exactly how that worked, I think you're torturing yourself, right? You're learning this stuff. I don't expect you to memorize everything on the first pass. It is 100% okay to go on back and try to find, the code that has the example that you're thinking of. Here it is. Here it is. This is printing out all of the even values from the loop. I'm now being asked to print all the odd values from the loop. Well, okay, I'm going to grab this if statement since I know that it already works for the even values, and I'm just going to take it back and just paste it right in and tweak it and make it work for the odd values, right? The name of my variable is different. It's not called number. It's called value. Okay, well, I'll change that. Here I'm saying if value mod 2 equals 0, that's how I know that it's even. But if it's going to be an odd number, I wouldn't expect it to be equal to 0. I'd expect it to be equal to 1. Okay? Now I'll say value is odd. And I believe I've done it, right? I believe I've accomplished what's been asked of me. This should print out all of the odd values from the array. Those do in fact look like odd numbers. And what I did there, right, grabbing a piece of code that I was already familiar with and modifying it, that's programming. That is 100% programming. I encourage you to do that. Some of the studios and assignments are written in such a way that we want you to do that. Borrow code from the studio, stick it in the assignment, and just modify it to suit the situation. To me, that shows good understanding of the code, right? The idea that you recognize the fact that this part is being used to check for evens and odds, and you know how to modify that to do something a little bit different. That to me shows great understanding of the programming concepts in place here. So copying and pasting code is not necessarily a bad thing in this class if you can adapt it accordingly. All right. Number 4. So number 4 is a little bit different. I'm not printing out the odd numbers from the array. I'm printing out the strings that occur at the odd positions, the odd indices. So, let me pull up the code here. Here is the array that we've been given, and this is position number 0, right? Position 1, position 2, position 3. So it's saying print out only the names at odd indices. So I want to print out 1, 3, and then if there was another one over here, position 5, I'd print that out, right? 7. So print out the odd indexes. Again, we have a choice. I can use a for loop, I can use a for each loop. Actually, you could use a while loop if you really wanted to. I think most people probably pick a for loop here. I don't think a for each loop is going to do the trick. The thing that I'm trying to accomplish very much depends on the address of the value. And remember that for each loops don't take the address into account. They iterate just by value, not by address, not by index. So I think we're going to need the classic for loop here. For int I equals, I is less than, such and such, I plus plus, or is it? We have to tweak these, right? So the first index for I normally be 0, but 0's even. So the first odd index is 1, right? The condition that I'd usually use here would be something like this, right? I is less than the length of the array. Is that still good? this tells us when to stop. Does where we stop matter based on whether I is odd or even? This is our termination condition, right? This tells us when the loop is supposed to stop. Or in other words, it says keep going as long as this is true. So if I is even, right, does that change our condition? Or if I is odd, does that change our condition? Does the fact that I is even or odd affect when we want to stop the loop? It does not. We want to stop the loop when we run out of values to check. Whether I is even or odd does not matter. Do you understand that? Do you understand why I'm making that distinction, right? I'm trying to say that this condition still works. This condition still works. Just need to make sure that I doesn't go off the end of the array. That's all. But over here, this is probably something that I need to tweak a little bit to reflect that I don't need to visit each value. I need to skip all the even ones. So if I've done this properly, I would expect to see Landon and Gabby get printed out. The value at position 1 and position 3. There we go. Yeah. Whoa, why did you do that? Oh, that's fun. Just turn my code green. Okay. I don't know why that happened. Doesn't matter. Next problem. All right, great. We're going to create a two-dimensional array. Oh, that text highlighting is really annoying, but oh, it's gone now. Cool. Problem solved. All right. They want us to create a two-dimensional array, and they tell us what names they want in this array. So they give us some names here that they want. It's an array of strings. So when creating an array, first thing is what type of things. So it's definitely going to be a string array. And then we know it's a two-dimensional array. In this case, just because they told us, I think, that they want it to be a two-dimensional array. They gave us 3 names for the first row, 3 names for the second row. I don't care what the names actually are, though. One thing I do want to point out is if you're doing this, I think it's entirely reasonable, to write your code in the same structure as the array that you're trying to create. I think that's a very wise thing to do. The computer isn't going to care about your spacing, so make it good for you to read. So here's my opening brackets for the entire array, and then each row also goes in brackets. So they wanted 3 names per row. I'm going to use the name of my cats. There's Franklin, there's Lindsay, and Sally. Right. And for the second row, I'll use my dogs, Howard, Norman. These are dogs both past and present. I don't have 6 animals in my house right now. I'm not running a farm. I do have 3 cats, though. But anyway. Oops, that's not where the semicolon goes. The semicolon goes over here. You can see that I've really gone out of my way. Oh, I accidentally forgot something here, didn't I? The name of the variable would help. Yeah, I've gone out of my way to structure this exactly like I wanted to. Oh, they want it to be called students. That would help, too. They already did us a solid and, gave us the code to print out all the values down here. If I run this, you should be able to see that it does get printed out. Interestingly, though, they just printed them all out in the same row. So the way that these values are printed doesn't actually show you that they're in a two-dimensional structure, right? If I wanted to, I actually could print these in the same way that they would appear in the two-dimensional array. You know what I'm getting at? Really, the only thing that I would need to do is once I get get to the end of this row, I would have to tell it to move down to the next row before it starts printing again, right? I think we kind of saw something similar a little bit last week. So since this loop represents the row that I'm on, I want to go down to the next row when I hit the end. So I'm going to come down here. This represents the end of that loop. So right before the end of that loop, I'm going to insert a line of code that says, go down to the next line. Just move to the next line. And if I run this again now, hopefully we'll see that the values that get printed out now actually reflect the underlying structure too. You know, do you have to do it that way? No, you don't, right? It's just, you can. You have that flexibility. Okay. I've got time for at least a couple more, I think. Test 6 says, all right, we're given this two-dimensional array, and they want us to pull out a few values. They want us to pull out the 47, the 51, and the 20. So we're basically asking what the address of these values is, right? So to pull a value out of the array, I type the name of the array. Because this is a two-dimensional array, I know I need two indices, a row and a column. And so really the question is, you know, what's the row and the column to pull out the 47? Well, that's the easiest one. Since it's the very first one, we know that's going to be 0, 0. The other ones you have to do a little bit of counting though, right? So to pull out the 51, that's on the second row. And if you want to, of course, you could, like I've been doing, try to restructure this, right? Second row. There we go. Second row, even though it's 1, second row, right? Because we count from 0. And then to get the 20, that's on row 1, column 0, 1, 2. So I'd say 1, 1, 2. Right? Can run this just to verify that we got those values, 47, 51, and 20. There they are. So this idea that you can look at an array and pick out any value you want, right? As long as you know how to get there. Test 7 is a very similar problem, so I'm going to skip that one and go to test 8. I think I'm going to do 2 more before I call it a day. Test 8 is a very straightforward question. It just wants you to say the number of rows and the number of columns, right? This is something that, you know, I know this because I've done it so many times, it's burned into my brain. I don't expect you to have it memorized, but I do expect you to know where to find this information. So it's in your notes, you know how to find it online, or you know how to find it in Eclipse, or something, right? I would expect you to know that this is something we've talked about, something that you've been shown how to do, even if you don't remember exactly how to do it. That's programming, right? Programming is not necessarily knowing exactly how to do every little thing all the time. It's more about knowing what's possible, what's not possible, and then having the confidence to look up the things that you're not sure about and get the job done and apply those. So, you know, the number of rows is always going to be the length. They wanted you to print it out, whatever. The number of columns, as we've discussed, is the length of the first row, which we grab by sticking a 0 in the brackets there. A lot of people remember this one but have a hard time. Oh, thank you, computer, for shutting down. That's great. Well, I guess I won't do that last problem then. Sorry about that. I don't know why that happened, but I was almost done anyway. So the point I was going to make, just to kind of wrap up my thoughts on this problem, was that for the exam next week, you know, you're almost certainly to see something like this show up on an exam, but I allow you to bring some notes with you to the exam. You can bring a sheet of paper with notes on it. So write this stuff down if you need to. That's okay. Yeah. Do you have a question? One sheet of paper. Yep. One sheet of paper. The rule is I should be able to pick up your sheet of paper in the exam room and look at it and see what's on it without having to do anything weird like put on a pair of 3D glasses or, you know, something crazy like that, right? Other than that, I don't care. So I actually can't see in 3D. So if you really don't want me to see something, I literally cannot see in 3D, which I don't know why that matters to you, but that's it. I'm done. I'd be happy. I know I ran out of time to get through the questions because the thing turned off on me. But if you want to see me go through any of these other examples that I didn't get to, please come to my office. I'd be happy to go through any of these with you. Ask on Piazza, send me an email, you know, whatever the case may be. All right, that's it. Thank you so much, everybody. I'll see you in studio on Thursday.